Block 1. Unveiling Spacetime's Fabric, a Cosmic Introduction. Hello, Cosmic Explorers, and welcome back to the channel where we tackle the biggest, most mind-bending questions in the universe. Today, we are embarking on a journey that will challenge the very foundations of your reality. We're not just looking at stars or galaxies, we're looking at the stage itself, the very fabric of existence we call spacetime. And we're going to explore a truly terrifying idea that emerges directly from the work of Albert Einstein, the possibility that this cosmic fabric isn't perfect, that it's not a smooth, unbroken sheet, but is instead riddled with wounds, scars, and potentially even holes, gateways to the unknown. What if the universe has secret passages, cosmic tears, and dead ends where reality as we know it simply stops? To understand these terrifying possibilities, we first have to rewind the clock and appreciate the colossal shift in thinking that Einstein gifted to humanity. For centuries, our picture of the universe was beautifully simple, elegant, and ultimately wrong. It was a universe defined by Sir Isaac Newton. In the Newtonian world, space was the absolute, unchanging backdrop for everything. Imagine a gigantic, invisible three-dimensional grid. Everything in the cosmos, planets, stars, you, me, existed at a specific coordinate on this grid. Space was the container, and time was the universal clock, ticking away at the exact same rate for everyone, everywhere, no matter what. Time was a separate, relentless river flowing forward in one direction, completely independent of the spatial grid. It was a clockwork universe, predictable and orderly. Gravity in this model was a mysterious force, an invisible rope that one object, like the sun, would use to pull on another object, like the Earth, instantaneously across the vast emptiness of space. It worked, the math checked out for most things, but it left a nagging question. How? How did the sun tell the Earth to orbit? How did this spooky action at a distance actually function? The universe was a stage and the actors moved upon it, but the stage itself was rigid and uninvolved. Then, in the early 20th century, a young patent clerk named Albert Einstein completely shattered this picture. He didn't just adjust the old model, he threw it out the window and replaced it with something far stranger and more profound. He began with his theory of special relativity, which revealed that space and time were not separate at all. They were intrinsically linked. The faster you move through space, the slower you move through time relative to a stationary observer. This led to his masterwork, the general theory of relativity, which redefined gravity itself. Einstein proposed that space and time are woven together into a single, dynamic four-dimensional entity, the fabric of spacetime. This is where the famous analogy comes in. Imagine spacetime is a stretched-out rubber sheet or a trampoline. Now, place a heavy bowling ball in the center. What happens? The sheet curves, it warps, it creates a dip. Now, if you roll a smaller marble nearby, it doesn't fall toward the bowling ball because of some mysterious pulling force. Instead, it follows the curve in the sheet created by the bowling ball. The marble is simply traveling in a straight line through a curved space. That, Einstein declared, is gravity. Gravity is not a force, it is the curvature of spacetime caused by the presence of mass and energy. The Earth orbits the Sun because it's caught in the deep gravitational well, the deep curve that the Sun creates in the fabric of spacetime. This was a revolution. The stage was no longer a passive backdrop. It was an active participant in the cosmic dance. The universe wasn't a clockwork machine. It was a dynamic, malleable cosmic trampoline. But what is this fabric? Is it a literal substance? Not exactly. It's a mathematical model, a four-dimensional manifold, but it's a model that has been proven to be astonishingly accurate. Every experiment we've thrown at it, from observing the bending of starlight around the sun during an eclipse to the detection of gravitational waves, ripples in space-time itself, has confirmed that Einstein was right. Space-time can be bent, it can be stretched, and it can ripple. It is the fundamental structure of our reality, combining the three dimensions of space with the one dimension of time. Every event in the universe can be pinpointed by 4 coordinates, 3 for its position in space and 1 for its position in time. This is the space-time continuum, the very essence of existence. So, if this fabric is real, if it can be warped and stretched by something as ordinary as a star or a planet, it begs a terrifying question. What happens when you push it to the absolute limit? What happens when you take an object with an unimaginable amount of mass and crush it down into an infinitesimally small point? Can you bend space-time so much that it breaks? Can you puncture it? Can you tear a hole clean through the fabric of reality itself? This is where our journey takes a dark turn, moving from elegant physics to the realm of cosmic horror. We are about to confront the most extreme objects in the universe, the places where space-time is wounded so deeply that our laws of physics collapse. We are about to stare into the abyss of Einstein's terrifying bridges.
Block 2. Einstein's terrifying bridges, wormholes, black holes, and cosmic tears. We've established that space-time is a real physical thing that can be bent and warped. Now we're venturing into the cosmic twilight zone to see what happens when that bending becomes so extreme that the fabric itself is pushed past its breaking point. This brings us to the first and perhaps most famous of space-time's wounds, the black hole. A black hole is not just a super dense object floating in space. It is a region of space-time that has undergone complete and utter gravitational collapse. It's what happens when you cram an immense amount of mass into a tiny enough volume. The curvature of space-time becomes, for all intents and purposes, infinite. The result is a singularity, a point of zero volume and infinite density, where our understanding of physics, space, and time completely disintegrates. Surrounding this singularity is the point of no return, the legendary event horizon. This isn't a physical surface you could touch. It is a boundary in space-time. Once you cross it, the curvature is so severe that there are no possible paths that lead back out. All paths, all futures lead only one way, inward, towards the crushing oblivion of the singularity. Even light, the fastest thing in the universe, cannot escape. A black hole, therefore, is more than just a cosmic vacuum cleaner. It is a fundamental wound in the universe. It is a one-way tear in the causal fabric of reality. Information that falls in is, according to our current understanding, lost forever, creating a paradox that has stumped physicists for decades. It is a place where the forward march of time is warped into a spatial direction, pulling everything relentlessly inward. It is a literal hole in the universe, a cosmic dead end. But the mathematics that describe a black hole contain a tantalizing and even more bizarre possibility. When the physicist Carl Schwarzschild was working through the equations of general relativity, the solution he found for a non-rotating black hole had a peculiar symmetry. The math seemed to describe not just an entrance, the black hole, but also a theoretical exit, a white hole, a hypothetical cosmic object that spews matter and energy out, but which nothing can enter. The theory suggested that these 2 points, the black hole and the white hole, could be connected by a throat or a bridge. This theoretical connection is what we now call a wormhole, or, to give it its proper name, an Einstein-Rosen bridge. This is the ultimate cosmic shortcut. Imagine our universe is a giant sheet of paper. To get from a point on the far left to a point on the far right, you'd have to travel all the way across the paper. But what if you could fold the paper in half, bringing the 2 points right next to each other, and then poke a pencil through, creating a tunnel? That pencil hole is the wormhole. It's a hypothetical tunnel through space-time that could connect 2 incredibly distant points in our own universe, or potentially even connect our universe to another one entirely. It's the stuff of science fiction dreams, instantaneous travel between galaxies, a gateway to parallel realities. It's a terrifyingly powerful concept, a bridge that bypasses the known laws of cosmic speed and distance. But here's where the terrifying part really kicks in. While these bridges are mathematically possible, they come with a host of nightmarish problems that would likely make them unusable, if not outright deadly. Firstly, the classic Einstein-Rosen bridge is predicted to be catastrophically unstable. The throat of the wormhole would pinch off and collapse into a singularity so quickly that not even a single photon of light would have time to travel through it. Anything entering would be annihilated in the gravitational collapse. To keep the throat open, you would need to prop it up with something strange. You would need a theoretical substance known as exotic matter, which possesses properties like negative mass or negative energy density. This isn't just matter that's weird, it's matter that would behave in ways that defy our everyday experience, like having gravity that pushes instead of pulls. We have never observed such matter, and we have no idea if it can even exist in the quantities needed to stabilize a wormhole. Even if you could find this exotic matter and build a stable wormhole, the journey would be hellish. The tidal forces near the entrance could be so extreme they would rip any ship and any person apart atom by atom in a process fittingly called spaghettification. Furthermore, the entrance would likely be a maelstrom of high-energy radiation, frying anything that dared to approach. So, are these space-time wounds, these black holes and their theoretical wormhole counterparts, just mathematical nightmares? Or are they a real hidden feature of our universe's architecture? We see the wounds of black holes everywhere, but the bridges remain elusive. Perhaps they are the universe's secret, terrifying shortcuts, waiting for a civilization advanced enough, or foolish enough, to try and cross them. The universe, it seems, is far stranger than we can imagine, with a fundamental fabric that can be bent, broken, and
Perhaps even tunneled through. What do you think lies on the other side of these cosmic wounds? Let us know in the comments below. And if you enjoyed this journey to the edge of reality, be sure to hit that like button, subscribe, and ring the bell so you don't miss our next cosmic exploration. Thanks for watching.